Okay, in this video I'm going to do a one-way analysis of variance in R. We need our data set up just as they were in SPSS, however we need to put that into a comma-separated values file. And since we have this data file from the last video, I can just, in SPSS, go to File, Save As, and save that as a CSV file. And I'll change it from SPSS data for one-way ANOVA to R data for one-way ANOVA and save. And now I will go ahead and open up R. I'm going to navigate over to the folder where I just saved that file, and I'm going to right-click onto that, right-click, if I can get that to work, right-click onto that file and go to Get Info in my Mac, go to Properties in Windows. I will copy this path to the file, so I have that in my clipboard, navigate back over to R, create a variable called myData, and assign to that variable a read.csv, open parentheses, paste that file in there, or the file path, add a /, go back to the properties or get info window, copy the file name, go back to R, paste that in, hit enter, and now I have my data. And it looks just like the SPSS file that we saw before. So how do we do an ANOVA in R? Well, that's simple enough. We simply use the AOV function. We can create a variable, something called results, assign to that variable AOV, and we can say my data rating tilde my data $version. And I want you to notice that the dependent variable or the outcome variable is on the left. And as far as I know, all of the statistics functions that I've used in R have the dependent variable on the left of the tilde as a standard. And just briefly, another thing, if someday you're doing another type of statistical test and you're going to have more than one, say, independent variable, you might have, dozens of variables in something. If you don't want to have to type in my data $sign all the time, you can use a different syntax that accomplishes the same thing. And it looks like this. So I can just put in rating tilde version comma, and then I say data equals my data, because that's our data frame called my data. And it does the same thing. Okay, so let's look at what our results were. All right, so we have a different set of results than we saw in our Excel file. Notice that there's a degrees of freedom 1 here for between, and a degrees of freedom 28 for within. Our F value is much higher, and our P value, of course, correspondingly much lower. I had to actually go to Stack Overflow to figure out what was going on. Stack Overflow is a great website. If you're having a problem in R, chances are that somebody has had the same problem and they've posted it on Stack Overflow. So a lot of times you can figure out what's going on using Stack Overflow. So this person says you have to save one of the variables as a factor, meaning a categorical variable rather than a numeric variable, which ours is currently stored as a numeric variable. So if we say like my data $, we just copy this person's format here, Tyler Rinker. Thank you, Tyler Rinker. And, whoops, that's a £. My data $version. And we assign to that itself, but sort of reformatted as a factor. Was it as.factor? Yeah, as.factor. My data version. and it looks like we've got that format successfully captured there. So now we should be able to reassign our results variable using the ANOVA function. And by the way, I'm pressing the up arrow key in R, and that's just going back to commands that I've previously typed in. And now you can see that our F value is 6.856, which is identical to the F value we computed in Excel originally, as well as in SPSS that we did in the last video. And we have degrees of freedom 2 and 27 that correspond to our own computed degrees of freedom. So again, same story with the p-value. The p-value is very low, so we can conclude that there's very little chance that the difference between the group means was due to chance alone. And that's how you do a simple one-way analysis of variance in R.